Hello everyone, myself Vinay Kumar M. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my last video, I was actually discussing the 12th chapter of 8th standard science subject, that is some natural phenomena. In this particular video, I will be discussing the 13th chapter of 8th standard science subject, that is light. So only when a light falls on a certain object and it gets reflected from that object, and when it falls on our eyes, then only we can actually recognize that particular thing. For example, let's say there is an object lying here, and if you want to see this particular object, then you have to put some light on this particular object. So the light actually falls on this particular object and the light will get reflected from this particular object. Only when light reflects from this particular object, when that particular reflected light will actually fall on your eyes, you can actually see this particular object. So to see any objects which is there around you, light is very much important. So we will study more about this light in this particular video. Now let us discuss about laws of reflection of this particular light, because now I have been told you that only reflection, like when light falls on certain objects and gets reflected, then only you can see that particular object. Either that object should emit its own light or some other light should fall on that object and it should get reflected. Only then that particular object can be seen. So there is some laws of reflection which is there, which is associated with light. So let us discuss that laws of reflection. Coming to the first law of reflection, so whenever a light falls on a particular object with an angle, with an incident angle, let's suppose say we have a mirror like this. So you can actually bring a comb or some wooden piece by making a small hole in that particular wooden piece. Then if you actually switch on the torch, so that this wooden block will block all the light, and only when light is actually struck by this particular torch, all light will be blocked by this wooden wall, and only some part of light will be allowed through this opening. So a single beam of ray is actually striking on this particular mirror. So this is actually known as incident ray. So let us call this as an incident ray because it is actually incidenting on the mirror's surface. So if you draw a perpendicular line at the point where that particular light is actually incidenting on mirror, that perpendicular line is actually known as normal. So this is actually the normal of this particular reflection. So now incident ray is actually incidenting on the mirror, and there will be a reflected ray from this particular mirror. So you can see here there is one incident ray and there is one reflected ray. So there is a certain angle created between this normal and incident ray, and there is certain angle created between this reflected ray and normal ray. So this particular angle is denoted as I and this particular angle is denoted as R, and this small I refers to incident angle. So this is actually incident angle. The angle which is made by the incident ray and the normal is known as incident angle, and angle which is actually made by reflected ray and the normal is known as reflected angle. So that is actually denoted as R. So you have incident angle and reflected angle. So what does first law states is that I, that is incident angle, will always be equal to the reflected angle. So this is the first law of reflection. Whenever there is an incident ray falling on a particular object, the reflected ray, if that object is plane, like this mirror should be plane and it should be straight, there should not be any irregularity on this particular mirror surface. If that is actually plane surface, then the reflected ray which creates angle between the normal, which creates an angle with the normal, and the incident ray which creates the angle with the normal. So those two angles will be equal. That is incident angle and the reflected angle with respect to the normal will be equal. So this is the first law of reflection. Now let us actually see what is the second law of reflection. So there are two laws of reflection. We have already discussed first law. Now let us discuss about second law of reflection. So to understand this particular second law, you can actually take a piece of paper like this. So on this piece of paper, you can keep a small mirror. So let's say this is a small mirror which is actually kept on that particular piece of paper, and now you can actually bring a small single beamed light ray, you can actually strike on this particular mirror, and as you know, like there will be incident angle and reflected angle which is actually made with respect to the normal, which is the perpendicular line drawn from this mirror. So now you can see there is some incident light here and there is a reflected light here. So you can see both the rays. Now you just bend the middle part where the actually this incident ray is actually meeting the point of that particular mirror. You can actually bend that paper a little bit like this. So when you actually bend this paper, you can see the reflected ray actually becomes invisible. There will be no reflected ray. But when you bring the paper to the normal position, like initial position, then you can again observe this reflected ray. That shows incident ray, like the incident ray and the normal which is drawn from that particular mirror, and the reflected ray. So all these three lie on the same plane. So incident ray, reflected ray and normal, all these three things lie on one plane. So this is actually the second law of reflection. So to understand this, you have done this experiment. Here you can see that this paper acts as one plane, and on this particular plane you can observe both incident and reflected ray. But when you bend this paper, you will not absorb any kind of reflected ray. But when you actually bring that paper normal like to its initial position, you can see the reflected ray. That shows both incident ray and reflected ray along with the normal lies on only one plane. So in whichever plane the incident ray is actually incidenting, on that plane itself reflection will happen, and on that plane itself normal will be there. So incident ray, normal and reflected ray will be on one plane itself. So this is actually the second law of reflection. So now let us understand the reflection which happens inside a mirror. So if you keep a plain regular surfaced mirror on the surface, and if you actually look at this particular mirror, so let's say there is one particular object which is placed on top of this mirror at a certain distance from this mirror, and you are actually looking at this object, the image of this object through this mirror. So let's say your eyes are here. So let us assume this as an eye, and you are actually observing the reflection of this particular object. So you will actually see the object is at the same distance from on the other side of the mirror. Here actually what happens is that there will be light coming from this particular object, and it is actually falling on this particular mirror plane, and it is actually getting reflected, and you are actually able to see this particular object. But the object which you are seeing is the virtual image which has been generated on the other side of the mirror. So if you actually extend the reflected rays beyond the mirror, then you can see at one particular point these reflected rays will meet. So at that particular point there will be an image formation. But this is not real image, this is actually virtual image. So whatever reflection of a real object you will see inside a mirror is actually virtual image. So this particular object which has got reflected in the mirror is real object. So the image which you are seeing of this particular object inside mirror is actually known as virtual image of that particular object. And one thing you should remember is that the distance how much this particular object is placed from the mirror, the image will also form at the same distance from the surface of this particular mirror inside the mirror. Let's say if this object is kept at d distance from mirror, then image will also form at minus d, or let's say d dash distance. The distance which is there, like that is the distance at which image has got generated from this particular surface, like mirror surface. So here d will be equal to d dash. So the distance of object from the mirror and the distance of image inside the mirror from the mirror surface will be equal. So whatever you are observing here is actually the reflected ray from the object itself, like reflected ray from this mirror itself, because there will be an extension of this reflected ray inside the mirror. So if you actually extend that ray, you will form an image here inside mirror. So that particular image you are seeing as the reflection of real object. Since that reflection is not real, the object which is there inside the mirror is not real, hence we call it as virtual image, which is not true, but image has got formed inside mirror. So that is known as virtual image. So you might have seen in mirror, you can see the lateral inversion taking place. That means the left side of an object is seen as right side inside the mirror, and right side of an object is seen as left side inside the mirror. So this kind of left and right alteration which happens inside the mirror, like with the image, with respect to the image which has formed inside the mirror, so that particular inversion is actually known as lateral inversion. So lateral inversion is the inversion of right and left of a particular object inside mirror, the image of the particular object inside mirror. So to understand this, if you stand in front of mirror and if you look at your body, you will not find any lateral inversions, because your body is perfectly symmetrical. Because if you actually draw a line from your head till toe, from the middle part of your body, you can see our body is exactly the same as our left part. Like our right part of the body is same as the left part of our body, and left is actually same as right. So that's why human body is perfectly symmetrical. So any body which has both right and left same, like if you draw a center line and you can see the same part which is there on both sides. You can see now, like one eye, and here also we have one eye, and here also mouth is divided into two. Here also every part of our body will be divided into two. So that's why human body is known as perfectly symmetrical object. So if you go and stand in front of mirror, you will not find the difference of any lateral inversion taking place. But if you actually keep a textbook or a notebook in front of mirror which has got some writings on it, then you can see the words which is there in that particular notebook will be appear to be inverted, or there will be a lateral inversion of that particular words. So only when you keep non-symmetrical objects in front of mirror, you can clearly see the left of that particular object has shifted to right, and the right of that particular object is shifted to left inside the mirror. Like the image which has got formed inside the mirror will have this particular lateral inversion. So now let us move further to understand this particular reflection. Let's say we have a very plain surfaced mirror and a reflection of light is taking place on this particular mirror. So let's say there are multiple rays which are getting incident on this particular plain surfaced mirror, and let us assume that all these incident light rays are parallel to each other. So now since this plane mirror is actually very much straight and there is no irregularity on the surface of this particular mirror, hence the reflection of this light ray will also be parallel to the other reflected rays. So that means when incident rays are actually parallel, like all incident rays are actually parallel, hence all reflected rays will also be parallel to each other. So if you consider this as incident ray, you can see all the incident rays are parallel. Similarly, all the reflected rays are also parallel because the surface is regular. So such kind of reflection which happens on a regular surface, on a surface where there is no irregularity, so such kind of reflection is actually known as regular reflection. So here mirror is actually plain mirror without any irregularities, hence reflection which happens on this particular mirror is known as regular reflection. So that's why here incident rays were parallel, and that's why reflected rays were also parallel, because the surface was regular. So see, this kind of reflection is known as regular reflection. So now let us say we have a mirror which has lot of irregularities on it like this. So let's say this is one kind of mirror surface which is known as irregular surface, because there is lot of irregularities which is present on this particular mirror. So now if we strike light on this particular mirror surface, let's say parallel incident rays are actually incident on this particular irregular surface. So now you can see all the incident rays which are actually incident on this particular mirror surface is parallel to each other, but reflection will not be parallel, because this particular incident ray which is falling on this part of mirror, so this part of mirror will actually act as plane surface for this particular incident ray, the first incident ray. But if you consider that in a broader manner, then all the surface of that mirror are irregular. But the point at which this first incident ray is actually incidenting on this mirror, that place will alone act as plane surface, and this reflection will depend on only this particular surface of this particular mirror. So here the reflection will happen in this particular direction with respect to this particular plane on the point where this first incident ray is actually incidenting. So this will be the one reflection. Here at this point the surface has actually changed. That means there is some irregularity. So here second incident ray's reflected ray will depend on this particular surface, and it will actually reflect in this particular direction. So now there is no parallel reflected rays happening. So now again one reflected ray will happen, like third reflected ray will happen based on this particular point where this third incident ray is actually striking, and the fourth incident ray is actually striking on this particular part of irregular surface. Hence the reflected ray will depend on this particular point. So it will go like this maybe. So next the fourth or the fifth incident ray is falling on this particular surface of this particular irregular surfaced mirror. So the reflection will depend on this particular point of the mirror. So that will actually go in this particular direction. Now you can see the rays which have got incident are parallel to each other, but the reflected rays are not parallel, because one ray is going in this direction, one is going in this, one is going in this direction, one is actually going in this direction, and one is actually going in this direction. So reflected rays are not parallel. Here incident rays are parallel, but reflected rays are not parallel. This shows there is some kind of irregular reflection taking place. So whenever reflection on an irregular surface takes place, so such kind of reflection is actually known as irregular reflection. So here actually irregular reflection is taking place. This irregular reflection is also known as diffuse reflection. So irregular reflection or diffuse reflection takes place on an irregular surface. So actually reflected light can also be reflected again. That means reflected ray will be reflected again if you have multiple mirrors kept. So to understand this, I'll just write reflected ray can reflect again. That means there is no rule that once if a light gets reflected, it cannot be reflected again. No, reflection can happen for a reflected ray as well. So at that time, that particular first reflected ray will act as the second incident ray, and there will be second reflection, and that second reflection will act as second reflected ray, third incident ray, and will create a third reflection. So there can be multiple reflections also. To understand this, we can actually keep a mirror. So let's say there is an object placed here, and let's say there are two mirrors connected right angles to each other. So if this is one particular mirror, and if this is another mirror, and there is an angle between these two mirrors, that is 90 degree. So the mirrors are kept at right angle. So now if you actually place an object between this particular right angle placed mirror, if you place an object in between these two mirrors, then the reflections which you can see inside this mirror and this mirror, if you count that reflection, that will be equal to, so there is a formula for this, number of reflection of this particular object will be equal to 360 degree divided by the angle between these two mirrors, because one light ray which is falling on this particular mirror is getting reflected, and this particular mirror absorbs that reflected ray, and it will also reflect that second reflected ray into third reflected ray. So there will be multiple reflections happening in between these two mirrors, because this mirror also receives light rays and this mirror also receives light rays, and there will be multiple reflections which is happening in between these two mirrors. So now there is an angle between these two mirrors. So that angle is right angle, that is 90 degree. So 360 degree divided by 90 degree minus 1. So if you actually solve this particular equation, you will get how many reflection of this particular object can be absorbed in these two mirrors. So 360 degree divided by 90 degree will be 4. So 4 minus 1 is equal to 3. So you can actually see three reflections of this particular object. If you have a single mirror and one single object, you can find one reflection of this particular object inside this one single mirror. So one reflection will be there because there is no other mirror. So hence there will be no multiple reflection. But if another mirror is placed right angle to this particular mirror, then you can see multiple reflection taking place between these two mirrors, and hence you can see one image here, one image here, and one image over here. So there will be three more images which has got formed of this particular object. So to understand that, we should actually substitute this n 90 degree. So instead of writing 90 degree, I will write a general formula, that is 360 degree divided by n minus 1. So this n is the angle between these two mirrors. So when you substitute this n, now it is 90 degrees. So I have written 90 degrees. So 360 by 90 is 4. 4 minus 1 is 3. So you can observe 3 reflection when the angle between these two mirrors are 90 degree. So let's say the angle between these two mirrors are 180 degree. Then what will be the answer? So 360 degree divided by 180 degree minus 1. So now you can actually solve this. 360 degree divided by 180 degree is 2. 2 minus 1 is actually 1. So you can find only one particular reflection. That is, so two mirrors, if they have 180 degree angle formed between them, that means they are actually lying on the same plane like this. So now you can see there is 180 degree formation between these two mirrors. So this angle is 180 degree. So now this two mirrors act as a single mirror. Hence there will be only one particular reflection of this particular object when you kept this object in front of these two mirrors. If you create no angle between those two mirrors, like let's say you have created 0 degree angle between those two mirrors, that means these two mirrors are parallel to each other like this. So if you keep the mirrors opposite to each other and if you place an object in between these two mirrors, then there is no angle actually created between this mirror, first mirror, and second mirror. So here the angle which is made between these two mirrors is 0 degree. So here actually n is 0 degree. Now if you substitute this 0 degree in this particular formula, 360 degree divided by n is equal to minus 1 is equal to 360 degree divided by 0 minus 1. So always you should remember, anything divided by 0 is actually infinite. So here the answer will be infinity. That means the reflection which you can see here, the multiple reflection which is taking place in between these two mirrors which you can see, will be infinite. That means there will be like lot of reflections taking place between these two mirrors. So there will be lot of multiple reflections happening. So if you see image in this particular mirror and if you see images formed in this particular mirror, you can see infinite number of images because there is no angle creation between these two mirrors, and these two mirrors are kept exactly opposite to each other. So the reflected ray which has got reflected from this first mirror will be reflected back by the second mirror, and that particular reflected light will again be reflected by this first mirror, and again there will be a reflection from second mirror. So there will be multiple reflections taking place, hence there will be multiple images formation. So since it is 0 degree formation between these two mirrors, there will be infinite number of images which you can absorb in these two mirrors. There will be lot of reflection which is happening in between these two mirrors itself. So that's why it is known as multiple reflections, and images which are actually formed in these two mirrors are known as multiple images because there will be a lot of images which has got formed in both the mirrors. There is only one object, but the image of this particular object will be n number of images will be there. So that's why it is known as multiple images, and the reflections which takes place is known as multiple reflection. So now let us discuss about kaleidoscope. So kaleidoscope is a device where you will actually take 3 rectangular shaped mirrors and you will actually join these 3 rectangular mirrors together, and you will actually bring one mirror upwards and one mirror upwards, and you will form a pyramid kind of shape like this. So when you bring this third mirror and first mirror, and if you join this particular end of this third mirror to the first mirror, then there will be a pyramid or a triangle shaped object like this. So this is one mirror, and this is second mirror, and this is actually third mirror. So three mirrors you have actually formed a pyramid using three rectangular shaped mirrors. So inside this you should actually cover one end, like there will be two ends of this particular pyramid. So one end should be covered with a drawing paper or a transparent paper where light can easily pass through that paper. So one transparent paper will be attached on this particular one end of this particular kaleidoscope, and you can draw a drawing on that particular transparent paper or a drawing paper, and you can stick that drawing part to one end of this particular kaleidoscope. So from other end you can actually keep that kaleidoscope facing to a light, and light will be passing through that particular drawing paper, through that particular drawing, and it will be seen from the other end of that particular kaleidoscope. So when this happens, there will be three mirrors which is actually kept inside. So there will be some kind of multiple reflections taking place inside that kaleidoscope, and the drawing which you have drawn will altogether form into a different kind of image formation inside, because you have drawn one particular drawing like this. Let's say you have drawn a circle. So there will be three mirrors which has actually kept at a certain angle like this. So there will be multiple images formation in this particular mirrors. So all these images will club together, and you can actually see a completely new image formation inside that kaleidoscope. By this you can get new ideas of designing things, because you have actually drawn one particular drawing on that particular transparent paper on one end of kaleidoscope, and from other end when you are observing, you are actually seeing that drawing. Along with that there will be multiple images of that drawing which has clubbed together. So you can altogether see a beautiful image inside a kaleidoscope. So that will actually give you new ideas for your new designs. So this is one application of multiple reflection taking place. So there is one more concept in this particular light chapter, that is dispersion. So how does a dispersion takes place? So if you have a white colored light which is actually incidenting on a prism which has a certain amount of angles which is maintained in that particular prisms, so that this prism will actually split the white color light into 7 different colors. So let's say 1, 2, 3, 4, 5, 6, 7. So 7 different lights starting from violet, indigo, it is actually known as Vib Gayar. So violet, indigo, blue, green, yellow, orange and red. So starting from violet till red, the color will be shifted. So red will be having larger wavelength, violet will be having lesser wavelength with more energy. So whenever white light actually strikes on a prism, that prism will split that white light into 7 different colors starting from violet ending till red. So this phenomena of splitting white light into 7 different colors is known as dispersion of light. So you might have observed in nature there is a normal dispersion of light taking place in the form of rainbow. So whenever sunlight passes through the rain droplets, there will be some kind of dispersion taking place by this rain droplets, and hence you can see a beautiful rainbow formation in the nature. So this is one example of dispersion, where dispersion takes place naturally in the nature in the form of rainbow. So now let us actually understand about human eye. You can refer your textbook for a beautiful diagram. I have written a rough diagram of an human eye here. So the outer part of this human eye is actually known as cornea, and the black color part which you can actually see inside your eyes is actually known as iris, and there will be a little opening in the center part of that particular black color which you can see inside your eyes. That is actually the opening where through which the light will enter the eyes. So that particular opening is actually known as pupil. So there will be one lens which is kept behind this pupil, on which when light rays actually fall like this, it will actually converge this particular light ray on the back side part of the retina, and the point at which light rays get converged, so this entire part is actually known as retina. So on retina the light will actually get converged, Hence your eyes can actually visualize the things which is there around us. So the light which has actually fallen on this particular retina is converted into information, and it is actually transmitted through nerves to brain. So these particular nerves which actually carry this information is actually known as optic nerves. So in this particular human eyes, there will be one particular spot on this particular retina which is actually known as blind spot. So on this particular spot, whatever light falls on this particular spot, retina cannot sense that particular light. So that's why that spot of retina is actually known as blind spot, and it is there in every human beings. So to understand about this blind spot, you can actually take a white color strip like this, and you can actually write a cross mark on one end, and you can leave some 6 to 8 centimeter distance on this white strip, and you can actually draw a circle, and you can actually shade this particular circle. So remember the distance between this X mark and this circle should be 6 to 8 centimeter. Now you can actually close your right eye, and you can actually focus the left part, like to the left part of that white strip you have actually written the X mark, and you can actually close your right eye and observe that X mark from your left eye. So while observing, you just move that white strip from right to left or left to right. So at one particular point you will see that circle will become invisible. That means that particular circle has come to that particular point where your retina cannot absorb that particular circle. So that spot is actually blind spot of your left eye. Similarly, you can close your left eye and you can actually observe the circle part, and you can actually move the white strip to right to left or left to right. So at one particular point the X mark will become invisible. That is the spot where your retina, like your right eye's retina, have its blind spot. So it is actually natural phenomena which all human beings have in their eyes. So there is no need to worry about this. So that particular spot is actually known as blind spot, where retina cannot sense the light in that particular region. So inside eyes, inside retina, there will be two kinds of cells present. So one is known as cones and the other is known as rods. These cones are actually sensitive to bright light. Similarly, rods are actually sensitive to dim light. So whenever there is whenever there is bright light present, then cones will be much more active, and whenever there is dim light present, then rods will be much more active. So in daytime cones will be active, and in night time when there is very less amount of light, when you don't have any kind of light source present in your home, whenever there is a power cut, whenever there is darkness inside your house, at that particular time your rods will get more active, because rods are actually sensitive to dim light, and cones will be active when there is bright light. So these are all the things which you should actually remember when it comes to human eye. So always you should remember the cornea is the protection of the eyes, and the iris, the black color part which is there in this eyeball, is actually known as iris, and there is opening in between that iris at the center part of that iris through which light enters, and the lens which is present behind that pupil is actually converging that rays on retina, and retina can absorb that particular light ray, and it can actually convert that into electrical signals, and that electrical signals will be transported through optic nerves to brain, and this brain can actually sense the objects. And there is one blind spot also there in this particular retina, and the cells which are present in this retina are known as cones and rods, where cones are sensitive to bright lights and rods are actually sensitive to dim lights. So all these topics related to human eye and light you should actually remember. So there are some amount of defects which is actually there in human eye. So whenever a human eye which is perfectly round in shape, then there will be proper convergence of light taking place on the retina of this particular human eye. But whenever there is bulging of this human eye takes place, the human eye is not exactly round, it is actually oval shaped. So at that particular point, the lens which actually converges the light rays will be, the point of convergence will be just in front of the retina. It will not actually converge exactly on retina like this, but it will actually converge at that particular point which is a little bit forward, which is little bit front part of this particular retina. So there will be no proper convergence of this light taking place on retina. Hence this kind of situation is known as myopia. So myopia is a defect of eye where it is also known as short-sightedness, where people with short-sightedness cannot observe properly the far objects. So that is known as short-sightedness, where their eyes are actually not round in shape, but their eyes are actually in a particular oval shape. So that's why there will be no proper convergence of light taking place on retina. Hence they should use some correcting lenses like concave lens. What does concave lens does is that if you have a concave lens like this, then this concave lens will diverge the light which is actually falling on this particular concave lens, and then this particular lens which is present in this eyeball will actually observe this diverged lens, and it will make this diverged lens to converge on retina. So based on the correctiveness which is provided on this particular lens will make to fall this particular diverged light rays on retina if the eyeball is oval in shape. So based on how much oval the eyeball is, that much amount of correction is given by concave lens. Hence it is actually known as minus powered lenses, because there will be subtraction of, because there will be much more divergence of light takes place, so that when the convergence of light happens inside eyes, it will actually make it to fall perfectly on retina. Hence this particular correction lens are concave lens. So similarly, there is another kind of refractive error which is there in human eye, that is known as hypermetropia. In hypermetropia, actually it is also known as long-sightedness. At this particular point, the human eye's lens will be unable to converge light rays properly on retina, but this human lens cannot converge properly on this particular retina. It will converge like this. So the converging point will be beyond this retina. Hence, people with hypermetropia or long-sightedness cannot see near objects properly. Hence, it is actually known as long-sightedness, where they cannot see near objects properly. So at this particular point, doctors will actually suggest to use convex lenses. Here, since the convex lens which is already present in human eyeball is not functioning properly, hence there will be additional convex lens which is actually provided in the form of spectacles, so that there will be proper convergence of light takes place on this particular retina. So in this case, if they wear this convex lenses suitable for their eyes, they can actually see the near objects properly. So these are some kind of refractive errors which is actually present in eyes, and there are so many other refractive errors as well. So that you will be learning in your biology subject. So now you have learnt about light, you have learnt about human eyes, and you have also learnt about laws of reflection, everything. So now what care you should actually take to protect this human eye, because human eye is a very good gift for humankind, so that we can actually see this world and we can actually function in this world using this eyes. So to take care of this eyes, we have to follow certain measures. We should actually wash our eyes frequently with cold water, so that we can keep this eyes cool, and we should actually use some UV protective glasses when we actually go outside in sun, and we should consume vitamin A rich food so that we can actually nourish our eyes. So whenever you are actually reading, you should actually use perfect lighting. We should not use brighter light, and you should also not use dim light which actually strains our eyes. So you should actually use perfect lighting while you are reading. So these are all the measures which you can actually take to protect your eyes. So by doing this, you can actually enhance the lifespan of your eyes. So if you consider owl and eagle, owl can actually see in night very clearly, but eagle can see in day very clearly, because eagle has more cones in it which is actually sensitive to bright light, and owl has more rods in it, or rods in its eyes, hence it can actually see in darker times. So the day birds will be having more cones and less rods, and birds which are active in night time have more rods in their eyes compared to cones. So there was a person named Braille who actually invented Braille system. So this Braille system will be having some kind of roughness is actually created on a surface. So a certain kind of roughness which is actually generated on a surface will actually indicate certain alphabets. So based on the arrangement of that particular roughness on the paper, there will be some kind of words and sentence formation. So people who cannot see properly, they can actually use this braille system. So in this braille system, they will actually rub the surface of that braille so that they can actually sense the roughness of that particular braille, and they can actually identify which words are connected and which sentences are formed. Through that, they can actually read books. So actually, Louis Braille was a person who was actually visually impaired. He actually invented this Braille system so that even people who are visually impaired can also read and write. So there are so many people who are actually visually impaired have done lot of achievements in their life. For example, Helen Keller, or for example, there are so many other scientists, there are so many doctors, there are so many people who are visually impaired have done lot of achievements in their life. You should remember, even a visually impaired person can also do the achievements. So this is all there in this particular video. So like this, if you want to learn more physics, chemistry and mathematics, then please do subscribe to my YouTube channel and stay tuned with my YouTube channel. Thank you.